So I want to pick up where I left off talking about code switching. If you'll notice, we've already gone over this first half of your table. Basically, if F is moving up, F is increasing, which should have positive slope. You can see it. If F is moving down, F is decreasing. This slope should be negative. And then here are the three ways that your function can be constant and your derivative is equal to 0. So let me go back to those cards that I had, or more like sheets that I had, that kind of lay this out. F is increasing, moving up, slope is positive, right off of the table. Flip that over. F is decreasing, F is moving down, F is negative. Okay, also on the table. F is constant. Here are the three ways F can be constant. In all three cases, your derivative is equal to 0. Okay, you need to make note cards where on one side it says F constant, the other side F prime equal to 0, right? Just so that you'll have an easier time code switching. F decreasing on one side, F prime negative, F increasing on one note card, the other side of that note card says F prime positive. All right, so I want to talk about what the table says. Let me show you that right here. Okay, it's this bottom half about F being concave up and F being concave down. Okay, so we're going to go over how you get this column here and then also this column that's here. All right, so let me look at this. And this says if your function is concave up. Now, we can't say anything consistently at this point about how F is behaving. We can't say F is consistently increasing because notice you'll see some decrease and some increase, right? So we're going to have to ask ourselves, what might we say in terms of the slope? So I'm going to draw in three seemingly random slopes of your tangent line right here, and right here. What we can say is all the way up to this point, you see that your slopes are consistently negative. Okay, right here, your slope is equal to 0. And then over here, all of these slopes are positive. So if I think about that, I'm talking about the slopes of the tangent. I'm not talking about the functions. I'm talking about the slopes of the tangent. And you can see that with the slopes that I've drawn. We're going from negative slope to 0 slope to positive slope. So let me just write some random numbers in. So F prime, if that was equal to, I don't know, negative 2, and we transitioned into F prime is equal to 0, and transitioned into F prime equals positive 1. Okay, so if you go from a negative slope, that's going to be smaller than a 0 slope, which is going to be smaller than a positive slope. So what we can say is as we move from left to right, we can say F prime is increasing. The slopes are increasing. If you're going from a negative slope to a 0 slope to a positive slope. So if you look at your table, you can see that that is exactly one of the relationships that we have. It is right there. Right? If your function is concave up, the slopes are increasing. Not the function, but the slopes are increasing. Okay? So I want to flip this over because we should be able to see something in terms of our function being concave down. So if this is F. Okay? So no, your function is not consistently increasing or decreasing. You can see you increase and then decrease. But we should be able to see a pattern with the slopes of the tangent line. So I'm just going to draw them in so you can see them. And we'll notice that over here, in this entire region, all of the slopes are positive. In here, the slope is equal to 0, and then over here, the slopes are negative. So as we move from left to right, we go from slopes that are positive to slopes that equal 0 to slope that is negative. All right, so let me just pick some random numbers. F prime, a positive number, positive 3. Go to F prime equals 0 to F prime equals negative 9, right? So hopefully you can see if you go, this number is bigger than that one, which is bigger than that one. So what can we say? We can say our slopes are decreasing. Right? So every time our function is concave down, it has decreasing slopes. All right, and let me show you that on the table. Again, the table is very helpful. Okay, so if you look right there, if your function is concave down, it has decreasing slopes of your tangent line. Now the other option is one that I'm not going to show you, but the only thing that's left is f prime increasing, f prime decreasing, f prime is constant at your inflection points. Okay. So here's the last one. Let me zoom out. If your function is at an inflection, we know that f prime is constant. Like that. All right. So there's only one more thing that I want to go over, and that is this last column. Let me show you the last column. Okay, before I move on, let me show you another note card that you should have. Right there on one side, you should have f concave up, the other side f prime increasing. One side f concave down, the other side f prime decreasing. One side f inflection, the other side f prime is constant. Okay, I'm telling you to make these note cards because I am going to give you a code switching quiz, which is basically all of the things in here just mixed up, right? Asking you to do matching. All right, so the last one that you guys have to remember is this one here. Okay, f concave up, f prime increasing, the second derivative is equal to 0. So the second derivative is just the derivative of the first derivative. You just take another derivative. So f concave down, f prime decreasing, the second derivative negative, and then finally f is at an inflection point, the first derivative is constant, and then the second derivative is 0. So the question is, how do they get this one? All right, so what I'm going to do is I'm going to toy around with these things that we already know are true. So what do we know is true? We know that if f is increasing, f looks like this, which means that f prime is positive, right? You should have a positive slope. You can actually see it. All right. So the way I like to describe this is as long as you're doing something consistently on both sides of an equivalent relationship, then you should create another equivalent relationship. So for example, if you had x squared equals 9, if I add 5 to both sides, I'll still get the exact same x, right? So as long as I'm consistent on both sides of the equation, then I should still get the exact same x, right? If I subtract 5 from both sides, I get back here. All right, so what I'm going to do is I'm going to write down these equivalent relationship. If f is increasing, then f prime is positive. Okay, I'm going to do the exact same thing on both sides. So and the thing that I'm going to do is I'm going to take the derivative. So this means if f prime is increasing, there's the derivative of that one. And then it says take a derivative of this one. Then f double prime is positive. Right? And oddly enough, this exact same statement is right on your table. Let me show you where it is. Right there. See? F prime increasing, F double prime positive, and if we were to go over, you can see that's the same thing as F concave up. Right? So these two right here represent one note card. Here's another note card, F prime increasing, F double prime positive, and then here's a third one, F concave up, F double prime positive. Okay? So we could do the exact same thing if we were talking about F is decreasing. F decreasing, It's biconditionally the same thing as f prime negative, right? If you want to sketch it out, you could see it right there. Right? Hold on a second. Right? So I'm going to take the derivative of everything. So if f prime is decreasing, this is the same thing as f double prime negative. And guess what? That too is right on your table. There it is. F prime decreasing, f double prime negative. Okay, so the last one follows if f is constant, then f prime equals 0. This is what that looks like, right? You end up having some type of a poorly drawn, but 0 slope. So if f prime is constant, then f double prime is equal to 0. And there's that statement right there. Right? So please have those memorized so that you can code switch like crazy. Because chances are I won't give you a question that is as easy as I did the first time. So the one I was talking about in the previous video, it is highly unlikely that I will give you a problem like that, this one, right? Where you start off with f of x and all of your questions ask you about f of x.